Now, before we leave this module of the lecture video and move into the game theoretic interpretation, let's just quickly go through a general terminology for optimization problems. Now, we have seen that optimization problems have constraints. And we say that a variable picking certain numerical value gives you a feasible solution if it satisfies all the constraints at the same time. And if this problem has no feasible solution, then we say the optimization problem itself is infeasible. Now, second, there might be infinite number of feasible solutions, which is typically the case in the optimization problems for this course. And then we're going to pick out the best one according to some minimization or maximization criteria in the objective function. Now, if a particular solution, let's say a vector x with a star on top to denote that it is optimal, we call this vector an optimal solution if it is A, feasible, because otherwise it doesn't even satisfy all the constraints, and B, it is better, or more strictly speaking, no worse than any other feasible solutions. Okay. Now, what do you mean by no worse than? Depends on whether you're talking about minimization or maximization. For a minimization problem, it means that it is at least as small as any other feasible solution will give you in the objective function. So if you pick any other feasible x star, stick into the objective function, which is denoted as f in general, then f evaluated at this x star vector will be less than or equal to that. That's if you are minimizing an objective function. Of course, if you are trying to maximize a function, then bigger the better. Then we say x star evaluated at x star for this objective function will give you an value for the problem that is at least as big as any feasible x vector. This then we call optimal solution. Okay. As you can see, sometimes there's no optimal solution. Sometimes there's one, and sometimes there are many, in fact, infinite number of optimal solutions. Later, we'll also try to make a differentiation between globally optimal versus locally optimal. The definition we just talked about, comparison with any other feasible solutions, that is global optimality. If you say that this is no worse than any other feasible solution in a small neighborhood around this point, then we call that solution locally optimal solution. So these are the terminologies about a feasible solution, globally optimal or locally optimal solution, that we will be using again and again in the future lectures.